Hello and welcome to this example on annuities. In the problem that we will see in a moment, we will have to work with an ordinary simple annuity and we'll get to apply some formulas that are useful to keep in mind when we work with that type of annuity. If you have questions, please write a comment or send me an email and contact me so that I can try to help you. Thank you for watching this video. I hope you enjoyed. Hi there! In this problem, we have that John will make payments of $50 at the end of every month to settle a loan of $1,300 at 3.90 compounded semi-annually that he received to purchase a television. We have two parts of this problem. First, how many deposits will he have to make? And we need to round up the answer to the next whole number. And then we want to know how long he will have to make these payments. Okay, to work with this problem, it's important to recognize that we're working with an annuity. And this annuity is an ordinary general annuity because payments are made at the end of every term. And because the term here is monthly, while interest is compounded semi-annually. So we have a mismatch between the term and the annuity term. Because we have a general annuity, not a simple annuity, then we need to work with an equivalent periodic interest rate. So let's work with that. Now notice that here the interest rate is 3.90% or same thing 0.039. And because interest is compounded semi-annually, we're thinking that interest is compounded twice a year. Then the periodic interest rate is given by J divided by M. So we have 0.039 divided by 2. Or 0.0195. Now, the number of compounding periods per number of payments per year is given by C. We have number of compounding periods per year divided by the number of payments per year and this quantity is equal to, so compounding periods per year, that's 2 because interest is compounded semi-annually, so twice a year, and the number of payments that John will make per year will be 12. So here we have 2 over 12. With that value of C, we can compute the equivalent interest rate, let's call it I2, by doing 1 plus I to the C minus 1, the interest rate we need to work with to make up for the mismatch between the compounding period and the payment period, is 1 plus 0.0195 raised to the 2 over 12 minus 1. And if we want to compute this using a calculator, you want to type in 1 plus 0.0195 power and then brackets 2 divided by 12, close brackets, and then take away 1. And that number is approximately equal to 0.003224, and we have some other digits afterwards. Okay. Now, once we have the C and the I we need to work with, there is a way to compute the number of deposits that John will have to make. That would be denoted by N. N is the number of deposits that he will have to make, and N can be written in terms of multiple variables in the following way. So let's leave some space here. We have n equals minus the ln of 1 minus I2 multiplied by the principal value divided by the payment, the value of the payments. Then we close brackets and we close brackets again, and then we divide by the ln, the natural logarithm of 1 plus I2. So in other words, we're doing minus the ln of 1 minus about 0.003224 multiplied by, and the loan is a loan of $1,300 divided by the periodic payments, that's $50. We divide this by the ln of 1 plus I2, and I2 is 0.003224, etc. And what we get out of this number is 27.2, which can be rounded up to 28. Now, if you're using a calculator, you want to use minus ln bracket 1 minus 0.003224 times 1,300 divided by 50, close brackets, divided by ln of bracket 1 plus 0.003224. All right. So we get about 28. So what we can say is that John will have to make about 28 deposits for the RRSP to accumulate to $1,300. So this is the answer to part A. That's the answer that we have to part A. Okay, now with the answer to part A, we can compute the answer to part B. So here was A. Now the answer to part B is about the term, the annuity term. And to find the annuity term, the amount of time that John will have to make these payments, we divide n by the number of payments in a year. So we have 28 divided by 12, and 28 divided by 12 corresponds to 2.333, etc. years, and that's 2 years and a third. In other words, 2 years and 4 months. The third comes from doing 0.333 and so on, equals 1/3, multiplied by 12, the 12 months, we get the 4 months. Therefore, John will have to make these deposits of $50 for 2 years and 4 months for the RRSP to accumulate to $1,300. All right, that's all for this problem. As I said at the beginning, you're welcome to contact me to write a comment or do anything you need to do to let me know that you need help, and I will try to assist you. Thank you for watching. Bye-bye.